a couple of core important topics last couple of weeks, compute, and then we discussed about storage. Now the third important core topic is networking. So even though networking we are discussing a little bit delayed in our curriculum, ideally network is the most important portion when you want to set up any IT infrastructure, IT landscape. So even when you discuss with customer, the very first thing that has to be sorted out is your network portion. So people call landing zone where the customer environment is getting created or the customer applications are getting hosted. So the very primary important aspect that we generally discuss is the virtual private cloud. So that is what we call it as VPC in short, right? That is the abbreviation, VPC. And so VPC is a networking layer in AWS cloud. So everything is software driven. Everything is virtual, right? When it comes to EC2 instances, it is a virtual computer. It is a virtual machine. And similarly, when you talk about networking, it's a virtual network. It's not the physical network. The physical network, in fact, is managed by AWS, the physical foundational network, like the backbone connectivity, the physical cabling, the routers, switches, which are physically located in the data center, that is being managed by AWS. But for our customer environment, from your application server to database server, or from your web server to the end user, so those kind of networking connectivity between the systems within AWS or between different cloud environment, or if you have some systems running on your own data center and you want to connect it with AWS, that's where the virtual private cloud, the VPC, comes into play, right? So virtual private cloud is networking layer in AWS, and this helps you to create a logically isolated section for the customer environment within AWS. So it creates a logically, or I would say virtually dedicated, isolated section or segment for customer workloads or customer environment within AWS within AWS platform, right? So or in other words, I would say VPC is a representation of customer network in AWS platform, AWS cloud. Okay, so in general, solutions architect take this particular networking into different dimensions. It all depends on what exactly the customer requirements are, and then based on that, they will create the VPC, and then they will subnet it, and then they will have all the gateway connections in place. So at a very high level, if you ask me what are the core important aspects of creating a network, the very basic fundamental thing is communication. So communication within AWS resources, it can be from your EC2 to RDS, or from your load balancer to EC2, or different connectivity within AWS. At times it might be between cloud environments, between the resources hosted in public cloud and AWS, or like GCP, Oracle, or even some SaaS platform connecting to AWS. You might need the communication, networking, and connectivity with on-premises, your own data center. So if you want to connect some resources running on your data center, like database server, or some data is present on your own data center, then for which networking, VPC is a very essential element. So communication is the very first one, I would say. The second thing is the isolation or the segmentation that we are trying to get. Isolation from other customers. So public cloud, AWS is a public cloud. Many customers are hosting their services, and we need to ensure that we are logically separated, or we are logically isolated from each other. So isolation from other customers who are running their workloads on AWS, and segmentation based on our needs. So some architects segment the VPC into subnet, maybe to segregate resources for different environment like production, non-production categories, test environment, sandbox environment, QA, UAT, SIT, and you can create as many number of VPCs to segregate the environment, or else you can also create multiple subnet within the VPC. So it all depends on how large is the environment, how big is the network landscape. If you have too many number of systems for an enterprise, then creating one VPC and isolating at the subnet level might not be a right choice. If it is a very small company, mid-sized company, creating too many VPCs is also going to be challenging because of the nature of handling the connectivities and so on, right? So it all depends on how big is the network landscape for your customer. If it is huge, then you can go for creating multiple VPCs in multiple AWS account, or else if it is a small to mid-sized company, you can try and consolidate them within VPC, and then there is an option called subnet through which you can segment the different requirement like environment, or if you want to have different subnet for different application, because some application might have different regulatory requirements. Some might have to be compliant with PCA standards, some might be less critical, some might be more critical. So business owners want to have a separate segment, separate network for their application. Some people might go with different departmental structure. So based on their regional structures, based on their departments, we might also go and segment it. So segment is to kind of create a logical isolation within your organization. I will help you with different use cases and scenarios shortly, right? And we also like your on premises, see, in when it comes to on premises, these are all pretty important basic things, right? You will have routers to route the traffic between different switches in your organization, or to external gateways, internet, or whatever. And then we might have switches at layer 3 and layer 2, and for connectivity purposes. And we might also have ISP providing modems and other stuffs, right? So you will have different physical components in your own data center. Here everything is logically driven. So routing is a inbuilt feature within your VPC, through which you can go and create as many number of route tables, and then you can route the traffic to a particular destination. It can be in the internet, or it can be on premises network, or if you want to connect to Azure cloud or Oracle cloud, you can also use this route table to route specific traffic. For example, some customers might have the web server running on AWS, and the database server running on Oracle cloud. So you can also use the route table for that purpose also. Or else if you want to connect allow some machines to connect to internet, you can also use the route table. And there are options to go and create filtering. Like there are many ways of filtering the traffic. You can use security groups at the instance level to filter the traffic, or secure the traffic. You can also use network access control list at the subnet level, at a larger scope level. You can go and use network access control list, or you can use network firewall service from AWS. So there are many different features and functionalities within your virtual private cloud that can help you to secure the traffic going to the internet, or to your on premises, or even within AWS. If you want to filter the traffic, or secure the traffic, you have options to filter it. And you can also do peering and create some private connectivity within AWS platform between two different regions, or between two different availability zones. Or if you want to have private connectivity from your EC2 instance to an S3 bucket, or to a RDS instance, so you can also do a backbone connectivity. So there are different options for peering. So primarily peering is to interconnect to different virtual private cloud, but you can also use it for connecting to a private endpoint or a service endpoint, so that you don't route the traffic through the internet. Instead, you are using the Amazon backbone network for all the connectivity. So at a high level, but creating a virtual private cloud doesn't incur you any cost. But if you are creating certain services, if you want to have some NAT gateway, or if you want to create some additional gateway, virtual private gateway, and so on, so those resources within your VPC are chargeable. But the dedicated network that you are creating for your customer, you don't have to pay anything. So until these days, we have not created any network, but then still the connectivity for our virtual machines, we were able to test something, and the connectivity was working fine, right? So the reason was, every region have its own dedicated default network, right? Default VPC. If you look at here for my North Virginia region, I have a default VPC that is already available. And if I go to another region which I have never used, for example, let's say Japan, I have never used. So if I go and check there, so in the VPC environment, you will see a default VPC there also. So VPC is a regional level construct. Okay, so this is specific to a particular region. For Osaka region, you have a specific VPC. So each region will have a default VPC, and within that, each availability zone, the data center will have its own default subnet. So VPC is the higher level construct, it's the regional construct, and subnet is a availability zone construct. If you go to subnet, each and every data center within that region, like 3A, 3B, and 3C, like if you have availability zone 1, availability zone 2, and availability zone 3, so each availability zone will have a default subnet. And all these default subnets within that VPC are interconnected or routed by default. You don't have to create an explicit routing for it. So subnets these within this VPC can connect to each other by default. So there is a default route that connects it. Okay, so there is a default route table or route. So within that region, you can see there is a default route table. If you go and check that route table, there is a default route that allows connectivity locally. So within this particular IP range, within this particular CIDR range, you have connectivity already. So these subnets will be within that CIDR range only. If you look at the ranges, it will be within that larger 16 segment. So if you are new to subnetting and networking, feel free to go through my networking session. I mean, sorry, the subnetting class. So that way you can understand what is happening. But these days, there are a lot of application tools, online calculators that are available where you don't have to really get into the details. But if in case you are still interested to understand how the subnet calculation works, there is a detailed 2 hours video that I have uploaded in the same playlist. You can just go through them when you get some time. So if you look at here, I'm just going and checking the range that we have got default, right? If I check this range, it says I can have IP address ranges from 172.31.0.1 up to 172.31.255.254, right? That is the complete range that I can have. And let me just go back. So one more thing, I will say this is like, let's say it's a class B range. So, and then if you look at here, I have subnetted that from so 172.31.0.0/20. So let me go one step back. For each and every subnet, I've just got this range. So here I've just got only a portion of range 0.1 until 15.254. That itself is 4096 IP addresses, and out of which 4094 IP addresses are usable. Because of the subnet ID and the broadcast ID, we will have the remaining IP usable for our system. So this slash 20 itself has got 4000 IP address, and the slash 16 has got almost how much, 65,000 IP addresses. So the default subnet that we get has potential to have up to 65,000 IP addresses uh, in that region. And then similarly, each and every subnet has got default 4091 IP addresses usable. So there is a difference in the calculator and the number that we see here, right? In the calculator, they said somewhere around 4094, but here they are saying 4091. So this is where you need to have a clear understanding. So when we go for the network IP address CIDR range choice, as a customer, we have to adhere to RFC 1918 document, which is a document that is for private internetworking. So this document says which are the IP ranges that we can use for your private connectivity, either on your own data center or within AWS public cloud or within your home network. So there is a RFC 191 and 18 document which has been created multiple decades back. Um, so you can go and go through that documentation from the Internet Engineering Task Force documentation. You can see that they have already defined what kind of ranges we can use for your customer internetworking or in your home network or office network or within AWS for private connectivity, private internetworking. You have to use these three ranges only. You cannot use beyond this. Who has defined this? Internet Assigned Numbers Authority. IANA is the global organization who manages the IP address, and they have defined that these are the IP address ranges which you can use. So if your organization needs a lot of IP address, if your organization is large to very large organization, then you can see that they have got 10 series of IP address. If your organization is medium, mid-size to large size, so you can go for the class B 172 range. In class C, this is mainly for your home network, or maybe if you're running a browsing center, or I would say a small size environment, right? So in these cases, you can use a 192 segment. 192 is a very smaller one. You can see that it has got /16, and this has got /12, and this has got /8. So /8 is the minimum that you can have for your VPC, but then you can also subdivide it. Generally, you can see a CIDR IP range of /16 to /28. So if you get some time today or tomorrow, like go through my subnetting session, that will give you a little more clarity on what exactly these numbers are and how we are deriving it, how we are calculating it. You'll get to understand it pretty much easily, right? It is not that tough. It is pretty much understandable. So if you want to create a VPC, so you need to define, I mean, you need to select which IP address to choose from. So from here, you can see that they have already chosen a particular IP range from class B, which is 172.31, and it says that these are the number of IP addresses that are usable per data center, per availability zone. So how these numbers are derived? So if you just go by the calculator online, this IP CIDR range, it says there are 4096 IP addresses, but then when we come and look at the VPC console, it says I can only use 4091. So where are those 5 IP addresses going? So these are the total number of IP addresses that I can have, but you can see only it is 4091 that is available for consumption. So the 5 IP addresses that AWS is reserving for these purposes. So AWS reserves 5 IP address for, see, even at your home network, you know that there is an IP address for your gateway device, for your router or modem, whatever you are using at home. It will pick up one gateway IP address. Similarly here, the very first IP address is not at all usable. For example, 10.0.0, or like in our example, it is 172 16.0.0. This is the network ID, which cannot be used for your system. And then the very first IP address, generally it is used for the internet, I mean the default gateway, right? Even in your home network, you can see that 0.1 is generally reserved for default gateway. And then there are a couple of more net IP addresses which are reserved for networking purposes, like DNS, or if you want to have some address spaces. So like 172.16.0.2, and then 172.16.0.3. So these are all kind of reserved for networking purposes, like DNS and other services. Same goes here. It is reserved for future use if in case we need additional DNS or additional IP address. So the last IP address is, let's say, 172.16.0.255, in just for an example. So this is the broadcast ID. So if you want to send a message to all the systems in that particular IP range or a network, you can use this broadcast ID to send a message. So broadcast ID also cannot be used on your system or your virtual machine or your instance or load balancer or wherever the IP address can be assigned. You cannot use it. So ideally, you can use the remaining IP address which are in between, right? So the first four IP address and the last IP address are reserved for a specific purpose, and that's the reason instead of 4096, the usable range is 4091 for your system. So this is how in each subnet, AWS reserves 5 IP addresses. So in each 5 IP addresses in each subnet for gateway connectivity and all those stuff, right? So coming to the next point. So at a very high level, if someone asks a question on interview why you need to have a virtual private cloud, these are the top 6 reasons. So if you start talking around these 6 reasons, you will start explaining more and more because that has got a lot of points to cover. So yeah, so VPC, as I told, virtual network is a kind of resemblance to your traditional network. In your on-premises, you might have switches, routers, and other stuffs. Similarly, here also you will go and create route tables, gateway, and other devices. We will create one by one. The VPC is dedicated to your AWS account. It is dedicated to your AWS subscription. So it is dedicated to your AWS account and a specific region. So it's for you. It's for the customer. So already we have talked about the public IP address, the elastic IP address, but we will also touch base on some of them. So there are many different services which leverages the public IP addresses, like your EC2, Elastic Container Service, EKS, EMR, global accelerators, load balancers, site-to-site VPN, RDS, Redshift, load balancing, workspaces, NAT gateway. So there are at least like 20 plus services that might use the IP addresses, either public or private IP addresses. So there are many services which consume it. So this IP address VPC is not just limited to your EC2, but this is definitely a networking layer for your EC2 instances for your virtual machines, but it is not limited to that. So there are other services like Elastic Container Service, which needs IP address, Elastic Kubernetes Service, Elastic MapReduce, database migration service, your Elastic Load Balancer, relational database services, MQ, the VPN, site-to-site VPN, or the NAT gateways, which includes NAT gateway or VPN gateway, the workspaces, virtual desktops. So there are many different services for which the VPC acts as a networking layer. It provides the IP addresses for connectivity with other services which are either within AWS or in your on-premises network. So that's where we are starting with. So when it comes to VPC, when it comes to network and content delivery in AWS, it is grouped at a broader level. It's grouped into 5 categories. Okay, so we will talk about the 5 categories first. So VPC intro, network categories. Okay, so at a very high level, so within AWS, the very basic network foundation. So network foundation within within AWS, you have to start creating the VPC, and within that you will have subnet, you will have route table, and so on. And you will also have the transit gateway. So if you have multiple VPCs and multiple network environment, and if you want to connect them to the on-premises via a centralized method or a centralized way, then you can go with this transit gateway. And you can also use the private link for connecting to AWS services or network via AWS network backbone. So AWS have their own network backbone across the global internet, which can help you to connect through their backbones, it will be much faster. You'll get enormous bandwidth with less latency and higher throughput and so on. So we'll see this private link in detail. So these are the very basic foundational components. And we also have this cloud WAN, which is also recently added. It's very much similar to your software defined WAN networking on the premises. So it is pretty much similar to it, but it has got its virtual concept, right? So it will have some difference. Let me just close this. Yeah. So this is the first pillar within networking. And the second pillar is hybrid connectivity. So hybrid connectivity. So of course, we will have systems running on different environments and networks. So we need to establish connectivity between these systems, either within AWS or with a different public cloud environment, or sometimes it might be on your on-premises environment. So we have these services like Direct Connect, Cloud WAN, Client VPN, Site-to-Site VPN. So this Cloud WAN is interchangeably listed, but we will have this client VPN endpoints. So client VPN endpoints at a very high level, it is mainly used for connecting the home users or the remote users or the roaming users. It is kind of a point to site VPN connection. So from a particular point, from your laptop or your desktop or from a specific device, from your mobile device also, you can directly connect with AWS platform. So this is a kind of a point to site VPN in general cases. Here in AWS, they call it as client VPN endpoint. What happened? Okay, there is some keep stuck here. Okay. So the next one is the site to site VPN. So if you want to interconnect two different sites, maybe a customer data center or Azure data center or different provider data center. So if you want to interconnect two different data centers or two different network, you can go and use site to site VPN. So that way you can connect two different, yeah, from the name itself, it is connecting two different site. It can be used for connecting two different region within AWS, but that is a very rare scenario. But it's primarily to interconnect two different network, either within AWS or between customer environment or different public cloud environment or different partner to partner engagement or business to business connectivity. You can have a site to site VPN. And the next one we have is the direct connect circuit. So from some of the on premises data center, customer data center to AWS, if you want to have direct fiber channel cabling or direct connectivity, you can go for direct connect circuit. This is again coming under the hybrid networking. The next category like cloud WAN, transit gateway, those are also kind of a foundation service which is nowadays used very in most of the cases, but it is a software defined WAN networking. If you want to globally connect all your network into one single management umbrella, then you can go for cloud WAN, which is a similar concept like a software defined WAN on the premises network. So we have these four categories here. And coming to the network security, or maybe before going to network security, we will talk about the edge networking, and then we'll go to that. So edge networking is mainly for the users from the internet or from outside of the AWS. So if you want to provide services for globally distributed users, and if you want to enable caching and other stuffs, then CloudFront is the pretty much more commonly used service. So this we can say edge networking and content delivery. So if you want to deliver the content global to the global users and to the users outside of AWS, generally we use this CloudFront, which is a kind of caching solution, or people call it as content delivery network solution or caching, or it's a one foot before your AWS environment. It is CloudFront, right? It is one stepping point before you can enter into the cloud. And you also have DNS service. AWS provides its own native DNS for internet name resolution, as well as for within resolution that you want to have within AWS environment. You can use this Route 53. So AWS Route 53 is a DNS offering or DNS service, DNS as a service that they are providing. So the number 53 here denotes the DNS port number, right? So that's why they have called it as Route 53. You also have global accelerator. If you have services which needs to be globally accessible, and if you want to have catches across different geographical locations, you can also use the traffic manager kind of solution, which is called global accelerator. If your end customers are scattered across the globe, and if they are roaming users, so this can help you to point the users, or you can create routing policies to route the users to a specific endpoint or to a specific region which is closest to that user or closest to the IP range that they are trying to connect from. So there are many different edge networking and content delivery services like those, and you also have a lot of security options, security network security services. So for some most of your internet facing applications, right, especially the internet facing application, but there are some solutions architect who might also enforce web application firewall for their intranet application. If they feel there are some intruders or some security concerns within your organization, then you can go for web application firewall, the WAP solution for intranet applications also. But predominantly this is intended for applications which are internet facing, so that you can restrict the web applications which are exposed to public internet or general public. So that is where this involves a lot of cost, and the more you create policies and rules, then the processing takes more capacity, compute services and so on. So you have to pay more for this. So only for the internet facing applications, generally we go for this web application firewall in most of the customer environment. But some solution architect, they prefer the web app for even some of the intranet applications for certain challenges, or if a customer explicitly asks for some rules and conditions that need to be applied on some of the intranet web application, you can also use WAF, but predominantly it is used for internet facing application. And you have firewall manager, network firewall, which is a combination to have a software defined firewall. Okay, so if you have multiple network firewall at a different region, you can also use firewall manager to manage all the global firewall related management at one single umbrella, one single place called firewall manager. So you have a lot of services. We will also discuss about some of the other services in the upcoming session. We have a detailed security and compliance. So we will discuss about shield, which is a distributed DDoS protection. We will also discuss about inspector and a couple of more services like config. But these are all networking level services. That's the reason we are listing it now. So it is not limited to all the security features. There are some more security related products which we will discuss. But here we are discussing something which is more used on the network layer, on the networking infrastructure, right? So if there is a distributed denial of service attack that you are seeing or that you are foreseeing, you can use shield to protect those DDoS attacks and similar uh, environment challenges. So the fifth pillar that we have is the application networking. This is more for the application developers, for their application to get connected with different SaaS applications or API and so on. So they call it as application networking. So before that, okay, so this is all fine. Remote access is also coming under that category. Okay, so network security and remote access, that's fine. Okay, so application networking. So the very first more commonly used service is the API gateway. Okay, where it is. So, okay, they are calling ELB and the lattice service here, but okay, so let's also have this ELB. But ELB is not it can be used at your infrastructure related load balancing as well, not limited to application networking, but API gateway, app mesh, and cloud map. Those three services are more used at your application layer. If you are having a lot of containerized environment, Kubernetes, if you want to have a fabric connectivity for your containerized workload, you can go for app mesh, or you can also interconnect your global application using cloud map. So it is just, I mean, I'm listing the names here. In the future we will discuss in details about how these are being used for certain use cases, right? I'm just categorizing it. So these are the five pillars within AWS networking. Even if you go to the AWS console, you can see that there are multiple grouping here for security, for firewall, for network firewall, for on-premises connectivity, transit gateway, for monitoring, and VPC ladder. So we have a lot of grouping. First, we need to be thorough on the VPC fundamentals, and we can go and explore the remaining interconnectivity and the security stuff. So first, we need to be strong on the networking foundation. We need to understand VPC, subnet, route table, transit gateway, private link. Then we can explore how to secure the network environment. So there are five different pillars to summarize. Okay, and the first thing, we have to be thorough on the networking foundation as an architect, and we can help the environment get secure when we go for hybrid networking or application connectivity between different customers and so on. We can use the right services to help them secure the environment. So any questions before we get into the topic for today? I mean, I've just given you some high level briefing and grouping on what exactly is VPC and network. Now we are going to practically create some virtual private cloud and subnets and so on. So before we get into that, if you have some basic questions or something you have in mind to get clarified, you can feel free to ask it now. Okay, fine. So I will consider that as no questions. So let's start. Coming to the slide here. So as you know, globally, AWS has got almost 34 regions, if I'm not wrong. I think, yeah, 34 regions are already active. There are six more geographic regions, AWS regions, that are being in plan. I mean, they are being deployed and getting ready. There are around 108 availability zones data centers across the globe, and there are 18 more which are in pipeline to be coming live very soon, in then this year or the early next year. So the global, the internet, I mean, all these AWS region which are scattered across the globe, they are interconnected with AWS backbone cabling. So they themselves have a dedicated private AWS fiber links. So these are all AWS owned connectivity between these different AWS region. And if you are, there are ways that you can utilize those private cabling, private fiber cabling from AWS. So that will help you to have the highest performance that you can achieve. So there is no bandwidth restriction, or there is no throughput throttling by default. So you will get a lot of alternate connections also. There will be like a lot of written in connection through different regions or different ways. So if you look at here, the connections are going all the way around. So from a particular region, you can see that there are multiple ways to reach it. So if the primary link goes down, you have written in paths to go to the same region via different connectivity. So globally, it is interconnected. AWS has laid their own networking infrastructure, networking cabling, fiber links between the regions. It has they have laid it across transoceanic cabling is there, and then you can see there are a lot of connectivity that are already there, and even you have provisions to connect your own data center with AWS data center using direct connect locations and so on, which we will discuss in details. So the connections between the availability zone within the same region, right? It is done using a metro area over dense wavelength division multiplexing. It is very high speed network. You have 82K fibers in a particular region, so it has got a lot of bandwidth. It is very high speed within the region, and even between the region also they have a very good link. So you will get a lot of single digit millisecond latency if you are using AWS backbone for your services. By default, AWS backbone is not the default connecting method. If you go for connectivity between region or from your region to internet, there is a default route is through the internet. But if you want to use the AWS backbone, there are methods and mechanism to have it implemented. I will show you, I will explain how to do that. So within the availability zone, you can get up to 25 terabytes per second of peak network you can get. So 25 terabytes of speed. I mean, people who are there in the IT for last um, 20 years, they know, right? We used to have 10 MB, 100 MB, and then 1 GB was a big thing. Now they are talking about 25 terabytes of speed with between two data centers, right, within a particular region in AWS. So the network has grown like anything. So you get a lot of speed, a lot of bandwidth, a lot of throughput with low latency. So AWS has laid their own fiber cable connections across the different geographical region. So if you want to connect your applications through through Amazon backbone, you can do it. There are various ways to do it. So it is pretty easy to set up and manage, and they provide you a lot of option to secure your connectivity, scale your connections, and so on. So we will get into that. We will discuss each and everything in detail, right? So provisioning a logically isolated section for customer environment in AWS, we need to have a VPC defined. So VPC is a regional level construct, and within that VPC, you have different availability zones where you can go and have your own subnet in each and every availability zone. That is the very first point that we talked about, right? So now we can go and define an IP address for our environment. So we have to choose one of them out of these three, right? As I told you, if your environment is very large, you can go for 10. If it is medium to large, you can go for 172. If it is a very small network and if you're just practicing and doing some labs, then you can start with using 192. Then you can start using the higher ranges based on the future requirement. So in AWS VPC, so you can pretty much use IP version 4 and IP version 6, both are supported. Okay, so for your first VPC, you have to define a CIDR range. So it is a classless interdomain routing range. That is the number that we use after the slash value, right? So you can generally use something from /16 to /28. So it depends on the numbers here. The reason why we are using /28, see if you go beyond, let's say I'm using /28. Okay, the number of IP address that I get is only 16 IP address. So if I give 5 IP address, the usable IP address for my systems is only 11, right? That is the minimum, or that is the smallest segment that I can have. See, if I go beyond that, if I, let's say /30, so I'll get only 4 IP address, which is way lesser than, I mean, which is already one IP shortage for the AWS connectivity requirement. So they themselves need 5 IP address. So you cannot have a CIDR range of 30 or less than 28 because of this reason. So if you go for 29 also, so there will be very, very minimal IP address, only 8 IP address. So with 3 IP address, we cannot have a environment, right? It is too small. So the smallest CIDR range, the segment you can have is /28, and you can go up to in general, most of the customers go up to /16, where you get up to 65,000 IP addresses, right? So hope it makes sense. So this is how we generally have to choose our IP range. So based on our customer requirement, if let's say like there is a customer who is looking for maybe like 100 servers in three different subnet, so you can go and choose something in 192 range itself. It is pretty much self-sufficient. So I can just say 192.168.100.0. I mean, it can be any number, right? It can be 0.0 or 1.0 or any numbers. So I'm just going with, so for /16, so you get up to 65,000. So this is the maximum that people generally go for. See, the more the number you go, some people will say like, I have got 200 IP address requirement. Why I cannot go and create a CIDR range which has got 2000 IP, right? So people might have this question. See, for your 200 requirements, going with a subnet range of 500 is okay, somewhat okay. But if you're going and reserving something at 2000, the broadcast domain, the broadcast IP range increases. For example, if the IP address has to be assigned, it has to check a very broader range. The 2000 is a huge amount of IP address, right? There, I mean, there won't be a big amount of latency difference, or you as a normal human with our human eye, you might not be able to find it out, but there will be a millisecond difference, or there will be some latency while it goes and checks for some conflicts, or when it want to assign a new IP address, or when it wants to send some traffic or packet to a particular system, right? So it has to traverse a very bigger range. So don't go for a very higher range to avoid the broadcast domain, or to avoid the network latency. Go and choose something which is closer to your requirement. Like for example, let's say I want to have an environment setup with 100 IP systems that needs 100 IP address. So always count the number of IP address. So you might have 60 systems. Each system might need 2 or 3 IP address, and you might end up having 100 IP address. Always calculate the number of IP address that might be required. So it's not always like one system needs only one IP address. Sometimes it might be more than one IP address also. So always go with the count of the number of IP address that you need. Let's say 100 IP address is what I need, and then for 100, there is a calculation that we can go and choose it. So that's where subnetting comes into place. It is pretty straightforward, easy to understand. Okay, so go and spend some time on my subnetting session, so that way you understand them easily. 2 to the power of 0, anything to the power of 0 is 1, and 2 to the power of 1 is 2, and then 2 to the power of 2. So it exponentially gets increased, right? 2, 4, 8, 16, 32. Okay, it goes that way. Okay, 2, 4, 8, 16, 32, 64, 128, 256. Okay, and then so you can keep going. So this is like 2 to the power of 3, 4, 5, 6, 7, and then 2 to the power of 8, and so on. So at a very high level, I will just give you a easier way to measure it or understand it. See here, for my requirement for 100 systems, I can either choose 128 or I can choose 256. So 64 is lesser than what I'm expecting, right? I need 100 IP address, but if I choose 2 to the power of 6, it might not be sufficient. Either I can go with 2 to the power of 7, or I can go for 2 to the power of 8. Considering a future expansion or a future requirement, I can go for the 2 to the power of 8, right? So how do we calculate the CIDR value here? So that is very easy. Okay, so in an IP version 4, if you are assuming that we are still using IP version 4, IP version 4 has got 32 bits, right? It is 4 octets, right, which is a combination of 4 into 8 bits, right? Each octet will have 8 bits. So we have a total of 32 bits, out of which we are saying like we need 8 bit for our systems, right? For we need a range of 8 for our virtual machines, load balancers, and other requirement. So out of this slash total 32, I am subtracting 8 here, right? In that case, I'm going to get, sorry, 24, right? So 24 slash 24 is what the number is. So let me just put it here. So this is what is our CIDR range here. If I want to assign slash 24 for the network, remaining 8 bits I will get for my system. So that is what the CIDR range here refers to. So if I can go, I'm just choosing a range of 256 IP addresses for my requirement from the calculator, and the calculator you can also denote it with CIDR range. So this slash 24 means 24 you are assigning to network, remaining 8 we are taking it for my system. That is what the slash 24 here denotes. So slash 24 we are assigning for my system. So in other way, like if you want to write it in subnetting or subnet mask, you can say 255.255.255.0 is assigned to my network, and this particular portion will change on my system to system, right? So the last 8 bits I'm going to use it for my system. So the CIDR here denotes 24 bits for network and 8 bits for my systems for my host. So that is what we have mentioned it as /24. The CIDR value /24 denotes that. Okay, so now coming to the VPC range. So I will go for 192.168.100.0/24, where I'm going to get 256 IP address. Within that 256 IP address, I can bifurcate, or I can subdivide based on my customer requirement. I can go and segment it as much as I want. So here, first thing, I'm going to create a VPC. So when you are creating a particular VPC, you can either go and create a VPC alone, or you can also create VPC with multiple subnets and route table and other gateway devices and so on. So it all depends on how you want to deal with it. So let's start creating a VPC first. I can just say stan VPC 01, and I can just give the CIDR range 192.168.100.0/24. And if I want to give some additional tagging, I can also create it. So I've created a new VPC for myself. So in order to differentiate this one, I will just call it as default VPC. See, few years back, I mean, most of the customers never use the default VPC. It is the same principle like how you treat your administrators, local administrator, the root user, and so on, right? So if you have some default credentials or default something, you don't use it because of the security reasons. It can be easily guessed, or it can be easily you can intrude in an easier way, right? So default VPCs, generally some customers go and delete it. Okay, some customers, they mark it as default, and then they don't allow resources to be created within that, and they ensure that only the customer defined VPCs are used for the customer applications. But some customers go and delete it also. So you have option to delete it, but if in case you have accidentally deleted that VPC, you have option to go and create a default VPC again. So earlier, few 5 to 6 years back, the default VPC creation, we have to take help from AWS and so on, but they have allowed the option these days. It is pretty much easy to create on our own now. So always ensure that we are on the right region. See, I have just swapped to a different region, and I'm doing all these things in Japan region, but that's fine. Okay, it is for testing purpose. And now within this VPC, I have to create as many number of subnet for our requirement. So I will just say to differentiate these things, I will 3CBA. So for each and every availability zone, we will have a default subnet. So I'm going to create a subnet for my requirement. So I can go and create select the specific VPC that I have created. And within that, I can go and create my subnet. Let's say like I want to have different tier, like let's say a web subnet, an app subnet, and so on. Or if you want to have production, non-production, or whatever category you want to group them, you can group it. Just for our demonstration, I'm just having these three here. So web DB and app subnet for my web application. Let's say I want to have, I want to create it in a particular data center. So subnets are confined, or subnets are associated to a particular data center. VPC is a regional level construct. You create it at the specific region level. So here I can go and specify the block that I need for my web subnet. So within that particular range, if I want to use something, let's say I have got 256, right? If I want to split them into three chunks of 64, then I can go and use this 2 power 6, which means I'm going and using 32, total of 32 bits minus 6 bits, sorry, minus 6 bits, which is /26. So CIDR /26 is what I'm looking for each of my web app and DB subnet. So here I will just say 192.168.100.0/26 is what I'm going to use it for my web. Okay, so that will give me around 64 IP address. So, correct, right? So 64, out of which 5 IP address will be reserved by AWS, and remaining 59 we will get. Okay, that's how you have to create it. So you always have to consider that 5 IP address that will be reserved for each subnet for AWS connectivity purposes. So similarly, if I want to create something for the app subnet, I can also do that here. So you can do all these things at the initial level itself, but for a better understanding, I'm doing it step by step, right? I can create it in a different region, or I can create it in the same region where I have created the other one. It all depends on our requirement. So here, the next range. So 192, 168, 100 dot. So here, what we have used, 64 we have already used for my, one second. Yeah, 64 we have already used for my first subnet. So 64 means always the IP address starts from 0 to 63. Since I've included 0 number, right? So it ends up with 63. So 64 IP address I've already used. So it starts with 0, right? And then it should end with 63 because we have taken 64 for this. So the next one will be 64, right? 192, 168, the next number. If you want to start from here, you can start it from here only, okay, /64. Or if you want to leave some space in between, you can leave it. I'm going to have the contiguous number here. So I will say, again, you will get 64 for my range. And if I change this number, automatically you will understand, right? See, for example, if I want 128 IP address, I can say I need slash what slash 27, or sorry, slash 25. And then if I want 32 IP address, it is slash 24. That's how it works. See, if I enter slash 24, it will say 32 IP address. Sorry, slash what I have entered there. No, I'm just writing in the wrong way. 24, 27. Okay, so this is slash 24. See, it is very easy, okay? 32 minus 8, 32 minus 7, 32 minus 6. That is the number I'm writing here. 32 minus 5, 27. Okay, so if I enter 27, you will get only 32 IP address here, right? So based on that, you can go and reserve whatever you want. Let me go for slash 26. You will get 64 and then create it. So that way you can go and create as many number of subnet that you want for your workloads. I can just close this. I can have a look at the subnets that I've created and the number of that are the IP address that are available. If you want to have a kind of different environment in different data centers, you can create production in data center 1, non-production in data center 2, and so on. If it is a very small environment, you can also subdivide like that. You can create test subnet, and then development subnet, production subnet, UAT, SIT subnets, and so on. So likewise, you can create whatever you want. So if I want to create a system on any of the subnet, let's say on my web subnet, I can go to EC2. Now this is where you will have focus on the networking section. So until this time, we have utilized the default subnet and we created it and things were working. So this time what I'm going to do is I'm going to create my system on the specific subnet that I've created, right? So here, let's say, I mean, I don't have a key pair here. Let me create one. Stan Asaka, 21 October 2024. Okay, so here is where the network settings comes into play. So by default, your systems will get created in default VPC. So as a customer, I don't want to go with default. I want to have my system created in my own VPC and the specific subnet that I have intended for that particular server. So the web subnet here. So if I create it, automatically you can see the difference that for the systems that we are creating in our own VPC and subnet, the auto assign public IP address will be disabled by default. For the default subnet, the auto assign public IP address is enabled. So auto assign public IP address is enabled by default for default VPC. So if you are creating some servers in default VPC and default subnet, the public IP address will be automatically assigned. But if you are creating a server in your own VPC, in customer defined VPC and customer defined subnet, the auto assign public IP address by default it will be disabled. So let's say I want to enable it, and I can also enable it. And here, this is where I go and create a security group and restrict the traffic. I can just create a security group. I can call it a Stan Web Security Group 01 for easier understanding. I'll just say this security group is intended for, this is just a description, restricting the web layer traffic. Okay, and if I want to allow a specific rule, I can go and say I want to allow HTTP because this is my web server, and I can also restrict it from an IP range. If I want to allow it from my on premises, I can give a particular range, or if I want to allow it from the internet, I can just give it a thing. Now let me go and launch it first and then see the difference. So this time what I will get as an IP address for this system, right? I will get it within particular range that I have defined. So I will get an IP address within this range. So as I told you, if I take this subnet as an example, the first IP address 192.168.100.0 is the network ID, which will not be used for my system because it is needed for denoting that network. And then the very first IP address, it's for the default gateway. Second one is also reserved. Third is also reserved. So default gateway, AWS reserved for network 1, AWS reserved for future networking requirements like DNS and other stuff. So I will get IP address from this range, any number from 4 to what is the last one? 63 is the last, right? So 63 is the broadcast. 192.168.100.63 is the broadcast ID, which can be used for sending traffic across all these systems here. So 4 to 62 is what I'm expecting. So any number, any IP address within this range can be assigned 168, 192.168, 100.4 up to 62. This is the range that my system will get as a private IP address. Let's go and check that. So if you look at here, it has got 100.5. So the reason it did not take the first few IP address because it is already reserved. So that is the reason it has skipped these IP address and it has assigned a IP address within that 4 to 62 range. So I've got an IP address of 100.5. If I create one more system, again it will assign an IP address within this particular range. That's how the IP address assignment works from the VPC subnet level. So if I go and create one more server, it will assign one more IP address like this. So if I want to access this system, let's say I want to access this instance from my local network or from my, it is still initializing. Let's give it a minute for things to come online. So if I have one more server in database subnet or app subnet, by default, there is a route table that allows you to have connectivity. So let's go to VPC. And then go to the route table. You can see that there are two route tables, one created for the default VPC and the other one has been automatically created for my own VPC. So by default, there is a route table that gets created, default VPC route table. And this is my stan VPC 01 route table. If you go through the route table here, it has got a default route with this range. This range is the overall VPC CIDR range. Within that, any number of systems that you have in app, DB, and web, it will be by default interconnectable. The connectivity between these layers are by default available. The local networking is by default enabled, right? That is something which you need to keep in mind. Route table, default route table for customer VPC gets created automatically. So there is a local route table that allows connectivity between subnets in the same VPC. But if you want to connect to another external VPC or external internet, there won't be any default option. Support IP version 4 and IP version 6. You know the difference at a very high level, right? So I'm not going to teach the details of IP version 6, but at a very high level, IP version 4, there is a limitation of 32 bits, which is nothing but 2 to the power of 32, which is somewhere around 4.3 billion or something like that. So this is the number of total IP address that you can have in your IP version 4. So that was considered as not enough not now, not recently, like 15, 20 years back, it was identified that IP version 4, we are going to overrun the requirement. There are few customers who are in transition from IP version 4 to IP version 6. You cannot directly transition it, or you cannot migrate it from IP version 4 to IP version 6. There you have to transition it in phases. So there might be like 5 years, 10 years, or even 15 years for some companies to transition from IP version 4 to IP version 6, because it is a very huge modernization, right, of your network. And that requires a lot of devices that supports IP version 4, the connectivity and all those things. So IP version 4 and IP version 6 can coexist in an environment for a certain duration. That is the transition duration, maybe 5 years or 10 years, depends on how large, how big is your landscape, and how many devices you are consuming for your customer. So based on that, you can have a transition period. So a lot of customers are having both IP version 4 and IP version 6. Very few customers have already gone into IP version 6 at a larger level, but many customers, maximum customers, are still utilizing IP version 4, which has got a limitation of 32 bits. And 4 billion IP address. So here it is 2 to the power of 128, which is huge, and somewhere around 3400 trillion IP address. We cannot, I mean, this is more than sufficient, I would say. So you can create slash 16 to slash 38 is the VPC size that I was telling earlier, right? So you can have slash 16 to slash 28 generally for your customers. And here you have, it goes in the increments of 4, okay? You cannot create every single thing. It has to be in increments. So slash 44 to slash 64, it's huge, okay? So you get enough amount of IP addresses. So the VPC IP address management solution here, so you can consider this console as a IP address management console. See, if you talk about DHCP, right? So what you do in DHCP, you go and create a scope with the IP range, and within that, automatically, if you have supernetting or just subnets, you go and specify what are the subnet for each and every department, or each and every particular environment. You go and define a IP DHCP scope, and that DHCP scope starts assigning the IP address for your system. That is the same thing happening here. So more or less, VPC acts as a IP address management appliance, or you can say IPAM solution, also IP address management solution, which also includes DHCP, DNS, and other stuff, right? So here also the same thing. VPC is more or less an IP address management solution, which also starts assigning the IP address like a DHCP server. Whenever you create a system behind the scene, VPC has inbuilt IP address management capability, which will go and assign IP address as we create load balancers, systems, and other stuff. So internet access, so both of them, okay, so has got this internet gateway. Some customer, okay, they might ask for only outbound access. So they will say, I don't want connectivity for my inbound, right? So I just want connectivity for my systems to go and access the internet. I want to download some packages, or I want to refer some documentations. I want to have some set step-by-step instructions available on the internet. So some customers will say, I want only outbound access to internet. I don't want the systems from the internet to access my systems inbound. So outbound access only to internet. And this is only for IPv6, okay? This egress only internet gateway. And for the IP version 4, you have something called NAT gateway that can provide the exact same functionality. So network address translation gateway. This can be used for providing outbound access to internet. So the inbound access through the NAT gateway is not supported. Internet gateway is a bi-directional gateway. So you can connect to the systems from my home to AWS. And similarly from here, if I want to connect um, the Google site, or my own website, you can also connect it. So yeah, it is pretty much bi-directional, right? So both from the internet, from my home also, I am able to connect the systems in AWS, and the systems in AWS is able to connect to this the internet hosted web servers or applications, right? So it is bidirectional in nature. And if you want to have IP version 4 only outbound access and you don't want to have inbound network connectivity, you can go and deploy a NAT gateway. There are two options. You can also have NAT gateway or NAT instance. NAT gateway is AWS provided service, NAT gateway as a service. Whereas if you want to have customer own proxy systems, or if you want to control certain things, you can also go and deploy NAT instance, but it is challenging in a way that you have to go and deploy multiple instances in multiple availability zone subnets, and you have to create load balances, clustering, and all those things. But if you go for NAT gateway or any AWS native solution, by default you get all these benefit, right? Because it is horizontally scaled, redundant, and highly available. So the clustering, the availability, the scalability, redundancy, it's all taken care of by AWS by default. So if you are creating something on your own like NAT instance or stuff, we need to ensure clustering, high availability, and there is a lot of overload there. You have to manage those operating system patching, backup, monitoring. A lot of additional things comes into our head. So if you want to utilize certain services, and if you have all the features and functionalities already supported by that particular device, then go for NAT gateway as a service instead of going for customer deployed NAT instances and stuff. So there might be certain use cases for some customers where they want to have control on the OS or control on some certain policies or some specific settings. Then you can go for NAT instance where a customer have control on the OS where the NAT instances are running. But if you're going AWS managed solutions like NAT gateway, internet gateway, or egress only gateway, it is gateway as a service. It is solution as a service. You won't have control on the OS layer. AWS will manage and maintain the configuration settings, standards, and so on, and they will be able to provide you the features and functionalities that are supported in that devices. So VPCs and the subnets can pretty much be integrated with Route 53, the AWS DNS solution. That is something which we will get to understand. So AWS native solution, you can use it for internet name resolution, as well as you can use it within your AWS platform itself also, right? So let's go and see if there is something which I've missed beyond this. So gateway level, I have already told storage gateway last week. So it's a gateway for connecting on premises to AWS storage. I think, yeah, gateway, those are the pretty much okay. There are another gateways like customer gateway and virtual private gateway, which we will discuss a little later. So when you talk about gateway, there are a few types here. Okay, let me not put it here. Okay. Okay, so there are many number of gateways that are there, and the purpose is the same. See, if you want to connect your systems to internet, connect your AWS instances, internet gateway. So the gateway to internet. And then similarly, if you want NAT outbound connection to internet, then NAT gateway can be used for IPv4. This is similarly for IP version 6. And this is for API connections from and to internet, business to business or business to consumer. This is application developer level of stuffs, API connectivity, connecting on premises to AWS storage gateway, connecting on premises or external network with multiple VPCs in AWS, transit gateway. Customer gateway is customer side of VPN connection. So the router on the customer's data center on the premises is called as customer gateway. AWS side of VPN connection, router or appliance on the AWS side of VPN connection. If you're creating a site-to-site VPN, there are two gateways that gets interconnected. So these are the things. At a high level, there are many different gateways that AWS offers for various purposes. So here, from the network level, yeah, we have started discussing about internet and NAT. We'll also we'll also discuss these things in details shortly. Okay, so any questions before we move on to the other areas?